All right, this is the fourth and final video on arc length, sector area, and volume. This video will focus on the Cavalieri's principle type shapes that are slanted off to one side and yet have the same volume of their straight up and down brothers. Okay, so this is a cylinder, and we know that the formula for the volume of a cylinder or a prism is area of the base times height. All right, so let's write that down. So volume is area of the base times the height. Okay, so Cavalieri figured out that that same formula will work regardless of if the cylinder is leaning over to one side or not. Just make sure you're measuring the height vertically. So the area of the base. So the diameter is 10, which means that the radius is 5. So when we do the area of the base, okay, the area of the base, we're talking about pi r squared. So that's going to be 5 squared is 25, so that'll be 25 pi. Okay, so that's the area of the base. So we can put that in there, 25 pi. Now the height they gave us is 12. All right, so it's just a matter of what's 12 times 25. That's 300. All right, so the volume is 300 pi cubic meters. All right, that's the exact answer. Let's go ahead and get the decimal as well. 300 pi. That's 942.48. All right, so that's number 23. All right, number 24 is almost the same thing. Again, the volume of a cylinder, even one that's leaning over to the side, is area of the base times the height. Now, this 8 is the diameter. That means the radius is 4. So that means the area of the base is pi r squared. So that's going to be 16 pi. All right, so the area of the base is 16 pi. Now the height they just gave us directly is 16. Okay, so it's just a matter of what's 16 times 16. Oops. 256. So we have 256 pi cubic meters. Okay, and that is going to be the same thing as, let's see, 256 pi, 804.25. All right, that's number 24. Now, number 25, the figures at right can be covered by equal numbers of straws that are the same length. Describe how Cavalieri's principle could be adapted to compare the area of these figures. Okay, well, it's an equal number of straws, so Cavalieri figured out that the volume would be the same by looking at slices of a three-dimensional object and figuring out that if you have the same number of slices, it doesn't matter whether they're stacked vertically or whether they're stacked diagonally. If you add up the volumes of each slice, the total volume will be the same in any shape. So that should work the same thing for area. So if you look at the area of any one straw, the total area will just be the sum of all the straw areas. So if these figures are all made up by the same number of straws, their total area is just going to be the sum of all the straws. And they have the same number, so that'll be the same area. Okay, so that's how you could adapt Cavalieri's principle. I guess I should write something down. Okay, so something like this puts into words what I was just describing. So that's it for number 25. All right, for number 26. So now we're getting into spheres. The volume, find the volume and the surface area of the sphere. All right, the formula for the volume of a sphere is 4/3 pi r cubed. So we know that the radius is 6, so that makes the volume 4/3 pi times 6 cubed. But 6 cubed is 216. It's a little too dark. All right, so that's 4/3 pi times 216. Anyway, I'll just put that in my calculator. All right, 4/3 pi 216. So that's 288 pi. Trenton, stop talking. And that's centimeters cubed. Okay, of course you can make that into a decimal very easily by hitting that toggle button. So that's 904.78. All right, now we also need that surface area. All right, the formula for surface area is 4 pi r squared. So that's going to be 4 pi times 6 squared. So that's 4 pi 36. So what's 4 times 36? Let's see, 4 times 36. That's 144. So that's why we had 144 pi. And this is area, so that would be centimeters squared. Don't forget your units. And of course I can make this into a decimal very easily. Just got to toggle it. Whoa, I forgot the pi. Whoops. You don't know me. 452.39. No. Lily, Lily, Lily. No one expects Lily. She gets you from nowhere. All right, so that's number 26. For number 27, the radius. All right, got to be careful because 21 is the diameter, so that means the radius is 11.5. Okay, 11.5 yards. Wouldn't it be 10.5? 10.5, not 11.5. Woo! Thank you. I would have made the whole video wrong. Okay. Oh yeah, that's another reason why the videos take so long to make, because I'll make a mistake, especially when I'm that tired. I'll make like 5 mistakes, and I'll have to go back and fix them. So that's why. Yeah, I'm just talking on this video. That's right, I'm talking on a video. No, I'm just gonna let it be the same. What was I gonna say? Yeah, volume. Volume is 4/3 pi r cubed. So that's 4/3 pi times 10.5 cubed. So since we have a decimal anyway, I'm just going to stick to the decimal this time. Okay, so 4/3 pi times 10.5. Whoops. Okay, so that's 4,849.05. Okay, and that's cubic yards. Okay, and of course surface area is 4 pi times the radius squared. So that's 4 pi times 10.5 squared. So that's 1,385.44 yards, square yards. All right, so that's number 27. All right, so we've got a sphere that is inscribed in a cube that has a volume of 8 cubic meters. What are the surface area and volume of the sphere? Blah, blah, blah. Answer in decimals, 2 decimal places. First of all, I can't really draw a sphere inscribed in a cube. So what I'll do instead is I'll just draw a circle in a square, and you'll use your imagination. Okay? So imagine that this is a cube instead of just a square. And imagine that this circle is a sphere instead of just a circle. Okay? Okay? So imagine that that is a sphere sitting inside of a cube. Let's see. Now the volume of the cube is 8 cubic meters. So let's start by figuring out what the sides of this cube would be. Let's see. Do I have a cube shape in here at all? Okay, so I can get a little cubicness happening. All right. So look, if the volume of the cube is 8, if it's a cube, all of these sides are the same, right? So how do I calculate the volume of a cube?
Length times width times height.
Right, isn't it just length times width times height, basically? So the volume of a cube will just be like x to the 3rd power, all right? So I know that x to the 3rd power, they gave me the volume, so that has to be 8. So what cube is going to give me 8? 2. All right, so the sides of this cube must be length 2. So this cube must be 2 by 2 by 2, length, width, height. 2 by 2 by 2. Okay? Now, so looking back at my little schematic here with my sphere inside of the cube, remember the length of this whole side of the box is 2. All right, it's 2 by 2. So think about my sphere in there. What's the radius of my sphere going to be? Can you see that if the entire box is 2 across, that means the radius of my sphere must be 1. Okay, it's going to be halfway across. So now that I know my radius, I can calculate anything I want. I can calculate the volume and the surface area easily. So just keep in your mind that the radius is 1. All right, 1 meter. So now if I want to find the volume, say, of my of my sphere, the volume is 4/3 pi r cubed. All right, but the radius is 1. So that would be 4/3, whoops. That's another 4. That would be 4/3 pi times 1 cubed. What's 1 to the 3rd power?
1.
It's just 1. And do I even need to really write the 1 down?
No, sir.
No, so I could just really erase the 1 to the 3rd power. So there's my volume right there, 4/3 pi. Because it's 4/3 pi times 1. And so I can just say the units. So since it's we had meters, so this will be cubic meters for volume. So that's the volume. Similarly, we're supposed to find the surface area. Yeah. All right, so the surface area is 4 pi r squared. So that's 4 pi times 1 squared. So again, 1 squared is just 1. So that's just 4 pi. So that's 4 pi square meters. So there's my surface area. All right? Do you understand now that I showed it to you? Okay. So that was number 28. All right. Number 29. They gave us the circumference, and they're asking us for the surface area. All right? So it's like I always tell you. If I give you some quantity, whether it's circumference or area or volume, if I give you a quantity, what do I always tell you to do? Right, set it equal to like the formula, all right? So what is the formula for circumference?
4 pi.
That's surface area.
Surface area.
2 pi r, right? So you got to know those formulas cold. So circumference is 2 pi r, and so they gave us the circumference. That means we need to substitute in for it. So that means 338 pi is going to equal this 2 pi r. So if I'll divide both sides by 2 pi to get the radius. So divide by 2 pi. Okay, cancel, cancel. On the left-hand side, the pi's cancel out as well. No more pi. So what's 338 divided by 2?
169.
169. So that's the radius. Now the radius isn't what they asked us for, but once we have the radius, we can find anything we want. So great. So what did they actually ask us to find?
Surface area.
Surface area. So once we have the radius, we can go ahead and go surface area. What's that formula again, sir? 4 pi r squared. And now we know that radius, so that's 4 pi times 169 squared. Okay? So 4 pi times 169 squared. Okay, so I get this at first. That's 114,244 pi. And we had meters, so this will be square meters. But they did say round your answer to 2 decimal places. So like on the test, if it specifically says 2 decimal places, definitely go ahead and give me those decimals instead. Okay? If you put both answers down, as long as they're both right, you're safe. 358,908.11. Okay, so that is the answer to number 29. And that is the end of this lesson.
See you.
I hope the video was helpful. I'll see you on the next video. You want to say goodbye, Jake?
Bye. I want to say bye.
Yeah. Anybody want to say something? Say it now.
Goodbye video.
Good looking, man.